Understanding the history of chip packaging is a quick way to know all about chip packaging. When it comes to the packaging of components, the first package that appeared in the world is 2. The crystal of components cannot be exposed, and it needs a shell to protect it, just like our internal organs cannot be exposed. This is the significance of component packaging. As for the packaging of TO, other types of TO packaging have been derived due to different uses, which will not be mentioned here. But you can save screenshots. As the first generation of transistors could no longer meet human needs, more complex integrated circuits gradually evolved. Unable to handle the increasing number of I/O circuits, DIP packaging was also developed. These 2 long rows of pins are not for nothing. Its main function is to perform through-hole processes on the PC board. If it's DIP 8, there are 8 pins. If DIP 16, there are 16 pins, and so on. Of course, DIP components come in 2-row pin configurations, but there are also single-row straight insertion types like SIP and zip. Highly integrated components still can't meet human needs, so they try to make smaller packages. By the 1970s, integrated circuits could already integrate 100,000 transistors. High integration, small size, and easy to use. This size was the SOP of that era. And in the world of SOP, there were different levels as well. For example, the SOP had a standard shape and surface mount packaging, which was cheaper. TSOP was more advanced with a thinner and smaller package. MSOP was a micro-sized package. SSOP was an even smaller pin count package. TSSOP is an even thinner and smaller pin count package, essentially the ultimate version of SOP. Of course, there were also even smaller transistor packages for SOT. If the integrated circuit of SOP is further evolved, it will evolve into QFP and QFN packaging. Their advantages go beyond high integration and small size. They also offer superior electrical performance and better heat dissipation. It can be said that this is the top-tier package for integrated circuits to date, suitable only for large-scale or even very large-scale ICs. At the same time, they have a relatively high number of pins. As few as 32 pins and as many as 144 pins are available. Even centipedes can't match it. By now, if you think QFP and QFN are top of the line, it's probably because you haven't seen these few packages. BGA, PGA, LGA. It can be said to further maximize the number of I/O interfaces on a chip. Just looking at its shiny exterior, you know it's no ordinary device. I/O circuit. Its purpose is to connect external devices. The more, the stronger its functionality. Most of BGA's pins are in the shape of small particles. A BGA integrated circuit like this can integrate hundreds of beads or hundreds of pins, which is not comparable to QFP and SOP. PGA pins are needle-shaped. PGA pins are also located below the chip, but PGA is in the form of needles. LGA is a grid array package. Its characteristic is that the pin layout design can be carried out according to the number of pins and functional requirements of the chip. That is to say, it can be customized. Every small chip is a small micro world. It is complicated, just like there are commercial areas, residential areas, and industrial areas, which are interlinked. A small mistake will ruin the whole chip, and the small universe of the whole chip will collapse. And there are countless such small worlds that have been created by humans, and more will be created.